Hello everyone, welcome back to Last Call BBS, playing 20th Century Food Court. And I guess in the last episode we left in the middle of Dwings here, right? That's what the level is called, I think. I was headed out on vacation, and I planned to be gone for a little bit longer than this, so there was going to be a gap in episodes, but I had to come back early, so I can just pick up where we left off. And from what I see here, I think this is a working, layout, if you could get the wiring all right. Right? The issue, as I recall, was how to synchronize stuff going into the fryer at, quickly enough. This sorter needs to hold things before pushing them into the fryer, because sometimes the fryer might be full, and it also needs to decide when to throw garbage away. And I remember I had this idea, this is like a week and a half ago for me, so give me a break while I figure things out again. I had this idea, which I haven't implemented yet, of counting setting. I think I need to count to turn each of these orders into 3 different things, right? How many chickens to dispense total? How many times I should send a chicken back through this thing before disposing. Like, if you send a full chicken through here, if you get a full chicken here, obviously you always want to send it through. And you get a half chicken back this way, which sometimes you want to split up into 2 quarter chickens again, but sometimes you want to throw the excess half chicken away. So we need to count how many times we go forward. So we have to count how many chickens we dispense, how many times we go forward, and then here, how many of them we fry before we throw away the excess. So as you can see, I don't have those 3 counters yet, but I think that was the plan. And I think it still seems reasonable. The issue was synchronizing all this stuff. And you can't just have this say, oh, I'll release something only when something comes out of the fryer, because at the beginning, nothing's in the fryer, so nothing will ever come out. So I was thinking about this for a minute or two before I started recording, and the best idea that I have for synchronizing all of that stuff is to have kind of invent a lock of sorts for these two to have a counter which we're using just as a variable. It's either 0 or 1 that says whether it's okay to push something right from this. And when we do push something right, we'll set that to false. And when we push something out of the fryer, we'll set it to true, saying, yes, go ahead and send the next one. And then at the beginning of the order, we'll set it to true as well, saying, okay, there's nothing here yet, you can just go ahead and dispense. And so this thing's sorter will be wired up to something that says, okay, go up if the number of things that you need to send to the right is 0, based on how many things were ordered. Go right if the number of things you're doing is non-zero, and this other variable that we're looking at is true. You're allowed to send something, right? And I guess we need another counter for the stacker. But that's easy enough. Ugh, this looks like so much work. All right. So I think we want a fancy counter for controlling this, right? Because if it's 0, we want to push forward. If it's greater than 0, we want to go right if some other input enables that, right? Geez. Okay, so we can at least put a +3 on this, a +6, and a +9 for the starting order sizes, because that's how many we want to send to the right before we start rejecting. And they don't care about the differences between cutlets and legs, which, when you cut up a whole chicken, you get a cutlet, a leg, and a half chicken. When you cut up a half chicken, you get a cutlet and a leg. So we're just treating the cutlets and legs as interchangeable. So that's fine. This is just how many things you want to send into the fryer. So if we get like a few multiplexers here for the input signals, if we get 3, we're going to send a +3. If we get 6, we're going to send a +6. If we get 9, we're going to send a +9 here. And so now this represents how many more we want to send right. And so we need a multiplexer with an enable to act as our kind of AND. And the worst part is, I think we might need 2 of them. Because we need to know not just when we're willing to send something right, but when we've succeeded in doing so, in order to decrement the counter, right? So the sensor on this thing has to be wired in as an enabler as well, I think. So like when this is positive, and there's something here, and the fryer control variable says it's safe, then we push right. So I think to do that, you need 2 of these, sadly. So when this is, when this is positive, and the sensor on B, where is that? Oh my gosh, what am I doing here? Oh, this was all like trying to say when the fryer is ejecting, you can send something else, but I don't think that works really, right? Like, what did I end up having at the time that I left? Okay, it never sends anything. Great. All right, so when we start, we dispense 1 chicken. But that's not enough, right? Because a single chicken only makes 4 parts. We might need as many as 3. So I'm just gonna rip out all this wiring. I don't think it was very, like, finished. Okay. Maybe, like, let's let this chill for a minute and just work on timing how many chickens we should spit out. Which I think you could do with a sequencer. I don't know if it's a great idea. By basically having, like, if you want 3 chickens, just, like, send out a chicken. And then you're done. If you want 2 chickens, send out a chicken, wait a while, then send out another chicken. And if you want 3 chickens, then, like, send out a chicken, wait a while, send out a chicken, wait a while, send out another chicken. So that can kind of be done with a few multiplexers and sequencers, right? But I think it saves us time to do this with timers, doesn't it? Counters? You can create a kind of sequencer, like a delayed loop from a counter, where you, like, you have a big counter that you can set to either 0, 1, or 2, saying how many spare chickens after the first you want to make. And that has a -1 that feeds into itself. But anyway, when it reads... actually, that seems hard. I was going to say, then when that's positive, it can send a signal to something else saying, all right, kick off a chicken, mate. But that other thing is going to be getting a signal saying kick off a chicken, like, all the damn time, right? It seems simpler to do it with sequencers, and I don't even know if it's more expensive or more space consuming. So what if I just say, like, where's my multiplexer for chicken dispensing? Here. So at start, we can dispense 1 chicken, kind of regardless of what's going on. And then if they want a 6-piece, we can say, yeah, like, make another chicken after this long. I don't know if that's long enough, whatever. And if they want a 9-piece, then... well, I'd better hope that's long enough, because that's about all the spare time I can give. Then, kick off another chicken after these times. Oh, of course, this doesn't test anything because it's our... Alright, let's, for now, wire... oh man, I don't know. Wire B's sense to its straight. Or, I don't know, actually to its right. Just so we can, like, test whether this dispenses enough stuff. So this is what happens if we only want 1 chicken. Very good, it kind of all gets there. What if we said we wanted 2 chickens? Ooh, it's getting a little tight there. If we had to wait for the fryer, I don't think we would have this kind of time. Right? And I bet 3 chickens is going to be kind of a nightmare. Well, it's not really any worse than 2, but the problem is, like, how long does it take to finish cooking all the parts from one chicken if you only use one fryer? Now there, I guess, is something I hadn't thought about. Why am I only using one fryer? Because machines are expensive, right? But wouldn't my whole life be simpler if I just used 2 fryers? I could put a fryer here and a fryer here, and then just alternate which way I send them and have them join up on their way out. Because then, like, going into a fryer takes you about 3 ticks, right? But but if we have the bits going into alternate sides, that amortizes to just like 1.5 ticks, doesn't it? And we would be like done cooking this top one probably by the time the next cutlet gets there. Yeah, plenty of time. The gap between this piece and this piece, which are the related ones that would both be going to the same place, is, 1, 2, 3. So that's plenty of time for them to both use the same fryer. Okay, I think that is actually a great innovation that I should have thought of a while ago. Just using 2 fryers. Because then, I don't know. I mean, you still need this to count how many you should send on before going left. I think these 2 sequencers are a pretty reasonable way to time how many chickens are made. Not to time, but to determine. Wait a minute. I don't need a sorter to do that, do I? This slicer is already separating them for me. I'm creating this headache for myself by reuniting them. What if I just didn't do that? What if I just put a fryer here and like a fryer here or something? And then had them join back up here? I do need a sorter eventually to decide when to throw away the extra garbage, but I can throw away the garbage after frying it. Nobody's charging me for the oil. So, what if my plan starts to look like this? Fryers here and here. Now, I think this still means there wouldn't be any conflict with the 2. Yeah, it's already time to release this, which means there's plenty of time before this guy gets in. Okay. And then the sorter gets so much simpler too, because it only ever has to send things forward or throw them away. Right? So, Now this whole logic gets simpler as well, I think. So when B senses... I don't actually even think I need a multiplexer there. It sends a -1 to this, saying, I have received one more thing. When this is positive, B should go straight. And when it's 0, B should go left. Right? So let's say we forgot the frying for now, so I don't have to wire those up. I mean, honestly, it's so easy to wire them up now. What am I even worried about? If we just have like 2 of these things with their own timers on them. Oh, although it was so, like, there was this whole problem with being able to reset counters being kind of hard. Okay, you know what? We're going to use large counters for this. It's a little embarrassing. Because large counters have a 0 signal you can use, or a positive and a 0 signal, which you can use to make sure they don't decrement themselves too fast. So... we need a multiplexer for the start signal, I guess, which I don't have yet. So these are the chicken signals, which are start or either sequencer. Start goes to a few places. The chicken dispenser, and it goes to the +2s on both of these. Now, these guys each need a -1, which sadly, I think we're using these guys. When these things sense something, and also the current value is positive, we decrement. When the value is 0, we eject. And then we're going to do the same thing again. When this senses something, and the current value is positive, you decrement. When the value is 0, you eject. Ah, except you don't just eject. You have to also add 2. Oh, so why don't I just have them add 3 when they eject? I don't remember why that seems like a bad idea. These are just stupid. So when you sense, you send a -1. Okay, I guess I do need these, but for a different purpose. When you eject, no, wait. When there's a 0, you both eject and add 3. Is that right? I think so. Maybe? We'll see. I've forgotten how this stuff, what was wrong with fryers. And what the heck happened here? When it's 0, you both eject and add 3. So does that work at all? This one seems to have gotten its counter reset to 2, which is all I wanted. These two collided, huh? Does that mean I sent out the chickens too fast? This guy got stuck, but that doesn't really matter. Yeah, I guess I did, because I wasn't ready to eject this yet. I cooked this as fast as I could. And the next chicken still arrived too soon. And boy, I do not have a lot of space to program this and this, do I? But I might not need much. Ugh, and the stacker too, yikes. I mean, to be fair, I've already done, I think, most of the work of programming this one, haven't I? Hopefully, in fact, all of it. So let's go back to order number 1, the simple 3-piece, and see what that does. It successfully throws away the 4th piece. And so we don't have the stacker programmed yet, but if we did, that would be a successful cook. Right? Or a successful order. So I think this piece is finished. This still needs a little bit of work, but not very much. Just basically another one of these wired up to the sorter that already exists. And this could just use a little more. Now the problem, really, though, that I haven't addressed is how do I stop myself from overloading either of these? Because we sort of have this problem that... Hang on, getting back to order number 2, please. This one is sent into the fryer first. But they both arrive at this sorter at the same time, which causes a backup, right? So, is there some way I can slow that down? Yes, obviously. I can give one of them a more circuitous route to get here. It's not, like, easy. And I can imagine it causing problems with future routes. I can't just delay both of them, because then I would still have the same problem. And I think the one I would want to delay is this one, because it's the one that's coming out fastest, right? And so I don't delay the slowest one, which means I finish a little faster overall. Okay, we can stop playing the frying noise. So the routing on that is like a little bit unpleasant. I can't delay things by a little. I kind of have to delay them by a lot. or else make bigger routing changes, right? I can go like left, up, fry, right. Like that's the best I can do. I think I'll try that. Just to see if that is the problem, like if that fixes the problem I'm having at all. Or does it just create contention later? Oh, man. Oh, they're willing to wait. They're waiting. Okay, I created a little block here, but I think that's okay. Oh my god, it's harrowing. Okay, now... This is not what we should have done to make 6 pieces, right? We made 8 instead. But incredibly, 8 pieces made it through the whole factory. Yeah, and then this thing just doesn't know what to do because it's got too many pieces, right? But 8 pieces made it through all of this without getting caught up on anything. So I wonder... I mean, if I made the last one and I sent in all 3 chickens, surely that can't go well, right? Because we are creating kind of a backlog here. Well... As long as we don't ever have a delay when we want onto the sorter and we can't get on, we get stuck in the fryer, that's actually fine. It's actually a fucking miracle? I somehow managed to fry up 12 pieces of chicken without ever getting them tripped on each other. Okay, that's incredible. I'm very pleased that that worked. And now... I think all I have to do is wire this and the stacker up, right? Because this needs to know how many chickens it should send straight. And then after that, it should send them to the right. Does it need a large counter for that? I think so, because it needs to be able to be given... Well, first of all, it's not how many chickens, it's how many times it should dispense forward. And that number is always at least 2. Right? Because you have to cut the first chicken up. And then you have to take the half chicken that comes back and cut that up as well. So we have to send either 2... Yeah, how many half chickens do we need, I guess is the question. So 2 if we're cooking 3 legs. 3 if we're cooking 6. And 4 if we're cooking 9. No. We need 5 half chickens to make 9 quarter chickens. So 2, 3, and 5 have to be the upticks on that. And then we need a -1 and a positive signal and a negative signal, right? So, or a 0 signal. Okay, so we definitely do need a large counter. So it needs a +2, a +3, and a +5, and a -1. This is the sorter, which has currently been wired up to always go straight, and now is going to get some adjusting. So when it senses, it sends a -1, saying, okay, you're sending 1 through. When the number is positive, we go straight. And when it's 0, we go right. I think that's it for this thing, except you have to give it its inputs, of course. But those are very easy. We already have multiplexers for these. If we're making 3, we say 2. If we're making 6, we say send 3. And if we're making 9, we say send 5, right? So now if I want to make 3 chicken pieces, I think I have everything but the stacker figured out. Hang on. Why is that thing pushing all the time? Oh, if it's positive, go through. Yeah, that's fine. As long as it's not decreasing the timer, or the counter, which it's not, because it wasn't sensing. It's fine if it always kicks stuff ahead. So this half chicken is the excess one, right? And indeed, this is on 0, so the half chicken is going to get thrown away. And then the excess quarter chicken is getting thrown away as well, right? Oh my god, it's a miracle. I have so much space to program the stacker. Okay, this is great. Also, it occurs to me I didn't need quite this much roundabout. Oh, no, I do, because this can't go... No, this could go up and then right, and then this could be the fryer. I'll try that once I've gotten this to pass. I suspect it would probably introduce some timing problems. Like, we just got very lucky that this sized delay happened to introduce no problems. I don't think there was any guarantee of that. And a smaller delay might be a problem. Anyway, okay, so... we just need one more counter for the stacker, right? I can't reuse the counter for this thing. But I just need one more counter, and I think that's it, yeah? So if you are making 3 pieces, hang on, 4, 7, and 10 are the inputs, which is 1 more than the sizes because we have to count for the tray as well. When this stacks, we give it a -1. When it's 0, we give it an eject. When we're making 3 pieces, we add a 4. When we're making 6 pieces, hey, come back. We add a 7. When we're making 9 pieces, we add a 10. Okay, I'm gonna go back to order 1 and press play, and we're gonna watch it, and it's all gonna work by some miracle. Hello? Oh, is the stacker not wired to eject somehow? Oh, right. I had these pluses, these +1s, because I was so used to my old system of using a sensor. But when you're using the stack signal, you should actually just use the number of things you expect. 3, 6, and 9. Okay, that was 3. Let's see 6. The spare half chicken gets thrown away. It's a miracle. Oh, I love it. And here's the Grand Royale, the 12-piece, or 9-piece? I don't know why I said 12. We threw away a half chicken and a quarter chicken. I'm doing great on time somehow. Oh, because I used only one. I used 2 fryers probably, and I bet the default thing most people did was to use 1. It was fun to pretend like I was a past person rooting for my sporting team or whatever. Worst date ever. The buffalo was an animal that didn't have wings. Buffalo, in this case, isn't the type of meat, but the town it originated in, blah, 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 blah. features something called a hot sauce, which causes excruciating pain. Apparently, this was something people like to do. Why? Yeah. So that's cool. If I like take this and copy it, and I try my alternative solution of this, do we still end up with no timing problems? I can't imagine that we do, but maybe. It looks good, actually, for 3. Obviously, that's no proof it'll work for the larger numbers, but I think it probably does work out, actually. Wow. Because the chickens are kind of entering this on alternating timescales, right? Yeah, interesting. Well, that saves me a bit more on time, getting me lower still. So if I just take this solution and delete it, I don't need it for anything, right? It only saves me 1 unit of, oops, 1 unit of time when I thought it might have saved a bit more. But it also saves me 10,000 bucks. I don't need this one for anything. Like, there could be some other improvements we could make here. But overall, I'm pretty happy with it. I even managed, like, to have things looking kind of uniform and nice in a way that I don't usually. Like, yes, okay, there's wires everywhere. But I have, units of functionality. I don't have wires reaching across the entire universe. This part, maybe you could save a few bucks by using counters instead somehow. I don't know. What was costing us time in this solution, I wonder? Well, for one thing, there's sort of a circuitous route to the end, isn't there? We have to go up through here and down. If we instead, like, took this whole thing and put it up here and reversed it so it was coming down, I could have the hot sauce applier, like, here, just dumping onto this conveyor belt there. That only saves us, like, 1 tick, though, right? Because I'm still going, like, from the sorter. In my dream world, I go from the sorter straight to the hot sauce applier when I put the hot sauce applier here or something. If you really wanted to push for time, you could probably dispense a chicken, like have a redundant slicer or something with 4 fryers? I don't know how you could fit all that. I don't know. So is there, like, I think back on the very first puzzle, it included some basic... Yeah, there's not really like a... There's control left click to clone a part. I forget, is this solution good? It's gotta be, like, perfect, right? Yeah, okay. Anyway, so there's no, like, copy a big chunk of the program, or of the layout. So, okay. Let's copy the solution and try the kind of reversed idea. Where you have something like this. This was on the right. and the left was what fed back. Oh god, I've already forgotten all the wiring for this. It's not hard, right? These needed to both go up. This one just had a fryer here. And by the way, I could flip these if I wanted. But for now, let's just try... I think this actually is making it slower, what I'm doing. But that's because I'm not done. Well... I would have the sorter, like... It's not really spaced the way I've done this, is there? I don't know, screw this. Delete the one that doesn't work. Alright, let's read our congratulatory letter. Greetings, operator. It's exciting times for the 20th Century Experience, and a few announcements to make regarding park operations. We are increasing mall and skate park hours to 24 hours a day. All operators role-playing as retail associates at the mall or as cool kids in the skate park will be assigned to one of 3 shifts. Keytars are now back in stock after last month's supply problems. While we realize this is what happens when you hand machine manufacture your products, we have very strong feedback from our visitors that they love the authenticity. Due to increased demand, we have introduced more jobs for visitors to try in the industrial zone. Additionally, many visitors have told us they are curious to experience 20th century burnout and existential despair, so we are spinning up a new office park area to explore how we can bring these once extinct sensations back to life. Thanks, the management. Alright. Well, what's going on with Breakside? We're obviously not solving that in today's video. No enthusiast of the 20th century can miss one of its most iconic repasts, the hamburger. Anthropologists believe that paying too much for a gourmet version of this inexpensive meat and bread assemblage was a cherished tradition among urban professionals. Well, you got that right. So, cool, but let's not do that right now. Let's see if I can solve one dungeon and diagram, even though I said I was kind of finished with it, which I still believe is true. The Eye of the Minotaur, alright. So that all looks good. The treasure room can't get up to here, can it? Because then there would be too few walls here, so the treasure room has to go down there. This column can't be part of the treasure room, I don't think, because then there wouldn't be room for 5 walls. The treasure room has to go that way. There's only one monster, by the way, the Eye of the Minotaur. So it seems likely that this 5 row is part of the wall of the treasure room and not part of the treasure room itself. But I don't think that's a guarantee. Well, obviously this can't be a wall, right? This would be a dead end. So there's only room for one more open space in this whole row. And it has to be here, right? That can't be a wall either. So we get all this. Well, then the treasure room must go like that, and this has to be the exit to it. Wow, that's instructive. Or informative, maybe? Okay, well, this puzzle is not looking too hard. Yeah. Well, we made it through one dungeon and diagram, as I promised. Let's see if I can do one more, since that one was so... Like, sometimes they're so easy, and sometimes I just spend hours, like... Okay, so far it hasn't been hours. But, like, grinding my way through options where I don't really see, you know, kind of any better plans than bifurcation. Okay, good start. If this were open, we'd have a problem, because this couldn't be wall or open, so it's closed. Likewise here, right? If this were open, this would be a problem. So that gets the column. This has to be closed now, and that gets the 3 column. And also these slimes. Pretty good. Another really easy puzzle. The corroded corridors, we got the slimes. Okay, give me a hard one. I mean, but like not that hard, please? We've seen this thing about ones passing through monsters before, so this should be news to nobody. That I'm filling in the rest of the 1 rows with opens. Now, I can't say for sure that this is part of the treasure room, can I? Could it be the exit? Well, no, because where is it going? This would have to be wall if it were exit. So that's, in fact, the treasure room. Oh, here's another one with monsters, by the way, so we can say all this stuff. Oh, these all have to be walls for the column. This isn't in a treasure room, so it has to be wall. And we found, actually, the exit to the treasure room, so we can say all this is... Yeah, okay. I guess it's possible I just came back from vacation with super brain. And that, like, all the puzzles were this easy and I was just stupid before. I don't think so, though. Alright, well, we knocked out 3 dungeons and diagrams, and I don't think I'm going to try a 4th right now. I'll just quit while I'm ahead. Hope you guys enjoyed. Thanks for watching, and I'll see you next time.